In our previous lecture, we discussed about energy and we discussed what is mechanical energy. And we know there is the mechanical energy is two kinds. One is kinetic energy and another one is potential energy. We discussed about kinetic energy in our previous video. Now we will discuss potential energy. So what is potential energy? The formal definition of potential energy is potential energy of an object is the energy possessed by it. So the potential energy is possessed by the object by virtue of its position or configuration. So this is the main point: position, position or configuration. So let us take an example to understand about position and configuration. The example. So suppose when a body is raised to a certain height, when a body is raised to a certain height, this body is raised to a certain height h, work is done against the force of the gravity. When we know the gravity is what in downwards and we use force upwards. So we use force to against the gravity. So this the work has been done against the gravity. This work is stored in the body as potential energy. So this work, like the work it possessed due to change of its position, like the body is at position A, now it is at position B. So due to this change, it possessed some energy. It possessed some energy. Why? Due to work. Due to work. This energy is known as potential energy. This work is known as potential energy. So what is this say? Virtue of its position means the change of its position. The body is at this point position A and now it is at position B. What is the configuration? Suppose let us take an example of spring. If we pull down the spring, the configuration of spring will change. Then this, because of this pull down, there will be some work done, and this work will possess some energy which is known as potential energy. So I think we get the main concept of what is potential energy and how it is possessed by the object and what is the virtue of its position or configuration. So I think we clarify this part. There are some classification of potential energy. So classification. There are some kinds of potential energy. One is gravitational potential energy. The second one is elastic potential energy. Elastic potential energy. The third one is electric potential energy, and the last one is magnetic potential energy. There are some classification of potential energy, but in this chapter we will only discuss about these 2 points: gravitational potential energy and elastic potential energy. For gravitational potential energy, we discuss this concept. So let us discuss this briefly. As we know, we take the body from A point to B point at certain height h. So it will possess some energy due to work. So and this possessed energy is known as potential energy. So we can write potential energy is equals to work done against gravity. Work done against gravity. So what is this work done against gravity? This work done against gravity is F into h. We know the formal definition of work is force into displacement, but here the displacement is height. Here our displacement is height. As this force is works against the gravity, work against gravity. That's why our F will be equals to the weight W. F will be equals to the weight W. And we know for W we use mg. To find out weight we use mass into gravitational acceleration. So this multiplication, this product is known as weight. So instead of F we will use this mg, and we'll find out the potential energy of a gravitational force is mgh. This is the formula of gravitational potential energy. So the formula of gravitational potential energy equals to mgh. So we discussed the first one, gravitational potential energy. Now coming to the second one, which is known as elastic potential energy. Suppose this is a spring at initial state. We pull this spring, we pull this spring from that point to this point. So this is our equilibrium point, x equals to 0, and this is our final point, xf equals to x. So we pull down the string with x distance. The displacement is x. Okay. So we actually in our work theorem we know for elastic or for spring we know F is proportional to minus of kx. F is proportional to minus of kx, where k is the spring constant and x is the displacement and F is the force applied to this spring. So when we applied some force to pull down this spring, then this is a relation, or this is one kind of formula for elastic or for spring. When we imposed some force, there the spring also imposed a force against this force. Imposed a force against this force. This is known as spring force. This is known as spring force. So we know F is proportional to minus kx, and for spring force F of s we know it is equals to kx. It is equals to kx. Okay. So if I want to find out the work done by this spring, we'll use this force for spring force, because we want to find out the work done by this spring. So the work done by this spring is equals to the potential energy. We represent this elastic potential energy as U. We know W. So here we have to find out the energy possessed from x equals to 0.2, xf equals to x point. So for this we will perform the integration. We'll perform the integration formula, because this is not a constant force, this is a variable force. Okay, this is a variable force. So for we know, suppose this point, this particular W point, for this W point, or you can say for this work dW, for dW, for this dW, the work is F into dx. This is the dx distance. For this dx distance, it imposes dW work. For this dx distance, it imposes dW work. So this work equals to force into dx, the distance it traveled. We know the formal definition. This is the formal definitions of work. So for total work, we'll use work 0 to W, and here we will use, as this is the operator is x, we'll use operator x to xf. So for this we will find out from this point to that point, it gives us the whole work W. So for this we will get the whole work W, which is equals to, for that x we know the equilibrium distance is 0 and final distance is our x into F into dx. And we know for F we can write, this is not F, we represent this as, we have to find out the force due to this spring. So we will use this Fs, and we know for Fs equals to kx. So we can write 0 to x kx into dx, as k is constant, spring constant. So we write down in the outer part of integration, and it is x into dx. If we solve this part, we'll get half of kx square. We'll get half of kx square. So we find out the total work W equals to half of kx square. So for our potential energy, it will also equals to half of kx square. This is the potential energy possessed due to work. So we know, so this is the elastic potential energy. I hope you understand the concept of gravitational potential energy and elastic potential energy, and you understand the main concept of potential energy. Hope you like this video. Please do subscribe to our channel and turn on your notification bar. Thank you.